This video is on linear equations in slope-intercept form. We're going to write equations from a verbal descriptions and graphs. So this problem, it says a cab company charges $3 upon entry and 50 cents each mile. The cost for the cab ride C depends on the total of miles M. That means we're going to, one, use the variable C and M in our problem, not Y and X. We need to know what our slope-intercept is, so we need to know what our y-intercept is, our starting value, and we need to know the constant rate of change for our problem. Cab company charges $3 upon entry. This tells you that that is a flat rate that no matter what, we will be charged $3. This is the value that we start with. This would be our y-intercept. Then it charges 50 cents each mile. Because it has that word each, it lets us know, hey, we're going to use this for per, for every. This is our rate. We actually now know what our y-intercept is, our starting value is, and what our rate is. So we want to write a now-next rule showing how cost changes with each additional mile. In order to do a now-next, we want to know what our next value is, knowing what our now value is. We know what we have now, so the next time we go, we're going to add 50 cents because we know that every mile we're adding 50 cents to it. But we always have to start at $3, so that means that we starting at $3. So the next mile, we know whatever we're at now, we will add 50 cents. So if we're starting at $3, we know that the next value we're going to have is $3.50. Then the next will be $4 because we're adding 50 cents each time. Now because of this, we can write the function rule or the equation. Rule means equation that gives cost of C after miles M have been driven. We can take this and use this to help us know which one is our constant and which one is our coefficient. Please remember that the y-intercept is your constant. That's your flat rate. Your constant was the $3, so that no matter what, we have to pay the $3. Every time we change, our rate tells us our slope. So to write our equation, we will use again, C depends. So that would be our y value. C depends on x, or C depends on miles. So we know our coefficient or our rate is 50 cents. So our coefficient will be 50 cents times our miles, so each mile. But we have to start at $3, so we're going to always have that 3. This is how we write our now next, and then we can write our linear equation from our now next formula. On question 9, it says a plane left Chicago at 8 a.m. and at 1 p.m. the plane landed 1,500 miles away in Los Angeles. We want to write a now next rule showing how the distance the plane is from Chicago changes after each hour. We also then want to write what equation tells the number of miles the plane is from Chicago, y, after x hours. We are going to use the letters y and x in this case. At this point, we need to figure out what our starting value is and what our rate is. Now our rate would be the change in y over change in x. We have starting at 8 a.m. and it flies until 1 p.m. Then we have 15 miles away. So it's change in y over change in x. So our y is going to be the distance, our miles, and our x is going to be our hours. So that tells us which one is independent, which one's dependent. So let's find our rate. Our rate, if we look at our coordinates, we know that it actually starts at, 8 o'clock. So our time, because we know that x is hours, I'm going to write it in a table. This is time, which is x, and we have miles, which is y. We know it goes from 8 o'clock a.m. to 1 p.m., and we know that it went 1,500 miles at 1 p.m., so that's 1,500 miles at 1 p.m. So if we think about, we know that if we're starting in Chicago and going to Los Angeles, we haven't gone anywhere at 8 o'clock yet, so that would be at 0 miles. Because we haven't started yet. So to find our rate, remember it is change in y over change in x. So our change in y is adding 1,500, and our change in x is adding the amount of hours. Remember that it goes from 8 to 12, and then it goes from 12 to 1. So that's 8 to 12 is 4 hours, plus 1 more hour gives us 5 hours. So remember, time goes to 12 and then it starts back over. So from 8 a.m. to 1 p.m. is 5 hours. So change in y over change in x is really equal to 1,500 miles over 5 hours. 1,500 divided by 5 is 300. So our rate is equal to 300 miles per hour, mph. So our starting value, again, it's the starting y value, was actually at 0 miles because we're starting at Chicago. We have 0 miles. Starting is your y values. So to write a now next rule, we want to know what our next value is, knowing what our now is. So as the distance, how the distance the plane is from Chicago changes after each hour. So it will change by adding 300 miles away from it. So we're going to add 300 miles away from Chicago every hour. But we start at 0 hours. We're starting at 0 miles away. 0 miles away, and then every hour we change 300 miles. Then the next hour we change another 300 miles until after 5 hours we get back to 1,500, means we're in Los Angeles. So to write the equation using y and x, so y is your distance, your number of miles, after x hours. We have y equals, because y is dependent on the number of hours, we use our addition, our rate, to represent our slope, because remember slope is constant rate of change. So our 300 miles per hour is our slope, 300, and it's the coefficient of x. And then we have plus our starting value, which in this case is 0, so we don't even have to put plus 0. This is our equation to represent the plane leaving Chicago at 8 a.m. and landing at 1 p.m. 1,500 miles away. This next question gives you a graph. The graph shows the total cost in dollars of buying D donuts. We want to find and interpret the slope. So to find the slope, we want to find the change in y over the change in x. Change in y over change in x. When you're looking at a graph, you want to find the location where the graph goes through like a nice clean cross. This location right here does not go through a vertical and horizontal line. It's only going through the vertical. So we have a coordinate here, and then we have a coordinate here. We have another coordinate right here because these are going through the vertical and horizontal. So we have to make sure we read our scale correctly. From this coordinate to the second coordinate, it has a change in y of a positive y, so it's positive 5. So our change in y is a positive 5 over, so divided by, we want to go to this coordinate, which has a change in x of a positive 4. So our slope is equal to 5 over 4. But we want to interpret it. Now this is $5 over 4 donuts. What that means, so we're talking about money here, $5 over 4 donuts. If we were to simplify this into money, we know that money uses decimals, we go to the nearest hundredth. $5 divided by 4 means that you can get 4 donuts for $5. That's a cost of $1.25 because we're dealing with money. This means that each donut, so each donut per one, costs $1.25. We can also say that you can get 4 donuts for $5. Using that same information from the slope, 4 donuts will give you can get 4 donuts for $5. Or you can say that 1 donut is $1.25. So let's write the function rule or the equation that gives the total cost C after donuts D have been bought. So again, we want to use the C and D. The Y value is the C. So we know it's going to be C equals. Slope-intercept form tells us we need our slope, which was $1.25, times our variable, which is D, plus our constant or our y-intercept. Our y-intercept in this case is 0, 0, so we don't have to put plus 0. This is our equation. You can also write the equation using the 5/4. So you can have it as or C equals 5/4 times donuts. Same slope, just a different, it's an equivalent slope, just a different format. So you can easily see your change in y over change in x when it's written in fraction form, but it might be easier to understand and interpret it when it's in this decimal format. So the last question says, the bakery gives a $2 discount if you buy a dozen. A dozen is 12. How much will you end up spending if you buy 12 donuts after the discount? So if we think about how much you would spend if you bought 12 donuts. So let's plug that 12 donuts into the equation we just came up with. So we have that the cost would equal to $1.25 times the 12 donuts. $1.25 times 12, this could also be written as 5/4 times 12. And please remember that 12 is written as over 1. This could easily be written as 5 times 12 is 60, divided by 4 times 1 is 4, which is equal to 15. So you would spend $15. But we're going to get a $2 discount. So we also need to think about the discount. So in order to get that discount, we're going to spend the $15, but then subtract $2 from the discount. So we will spend $13 after the discount. If this graph had kept going, we would have seen that at 12 donuts, it would have hit the 15 mark. But because they're given a discount, we don't actually have to spend the 15, we only have to spend the $13. This is how you read the graph. So again, you want to go to a nice clean corner and then count carefully your change in y and then count carefully your change in x. Because even though this only went up one line, it went up $5 in value. Your scale is very important to consider.